Hi guys, this is lesson 5, exercise 9F, traversable graphs. Now, a traversable graph has a trail that includes every edge within the graph. So the graph opposite is an example of a traversable graph. It has a trail that includes every edge. Now, there are different ways, but this specific trail, we can go from A to B to C, to A again, back to A, and then back to C. And you notice that every edge was included. Now, even though we've repeated the vertices, that's fine. It includes every edge, and there are different ways I can go from A to C, back to A, then to B, then to C. That's okay. Now, this is an example of a traversable graph. You've got to notice that not all graphs are traversable. So, for example, it is impossible to find a trail in this graph here that includes every edge. And you can, if you want, try it and see. You can start at A, go to D, C, A, B, C. Yeah, there's no possible way to make this traversable. And if this is the case, you will say that is a non-traversable graph. So there are rules to see if a graph is traversable or not. So for a graph to be traversable, it must obviously first be connected. A connected graph is traversable if, and there are two conditions. The first one, all vertices are of an even degree. And the second condition is that exactly two vertices are of odd degree and the rest are of even degree. Now, from this, it follows that a traversable graph will have either a trail, a circuit, or a cycle that involves the use of every edge in the graph. And if a graph has more than two vertices of odd degree, it's not traversable. So we want to focus on these 2 points here. All vertices are of even degree, or exactly two vertices are of odd degree and the rest are of even. We go back up to this one here. By the degree, you got to remember it's the amount of edges that either go out or go into that vertex. In this case, A has 3, C has 3, and B has 2. So for that one, it follows not the first point, but the second point. Exactly two vertices are of odd degree, which is the case. There was two of them, there were 3. And the rest are of even degree, that last one, that had a degree of 2. So it follows that point here. That's how we know it's traversable. But here it doesn't work because there's 1, 2, 3. It's actually 3 of each degree for each vertex. It says here, if a graph has more than 2 vertices of odd degree, which it has 4, it is not traversable. So I knew for a fact that this is not traversable. So the key component of determining if a graph is traversable is to identify the degree of each individual vertex. That is the number of lines coming from each vertex or going. Same thing. So here are these 3 examples. And for each of the following graphs, we're going to A, determine whether the graph is traversable, and state why. B, if it is traversable, we're going to check by identifying if there's a trail or a circuit that traverses the graph. So this first one here doesn't necessarily make a difference if it is planar or non-planar. We're checking the degree of each vertex. They're all even, 2 in each one. So we say that it is traversable. All the vertices are of even degree, and we can determine that this is a circuit. So we can start at any vertex, go to each one, and we've created a circuit. Okay, so it's traversable. Second one, again, you're going to count the degree of each vertex and see if it's even or odd. This is 2, so it's even. 2 if it's even. 2, so it's even. And 3 and 3, so they're both odd. 2 are exactly of odd degree. The rest are even. So again, you can say it's traversable. So in this case, your reasoning behind it is 2 vertices of odd degree, the rest are even. This is why it's traversable. And here we've created a trail. Okay, created a trail. So we can start here. And we've created a trail. Last one, count how many degrees come out. 3, 3, 3. Automatically I know it's not traversable because 4 of the vertices are of odd degree. And if it is traversable, well, it's not. We can say it's not applicable. And that concludes Lesson 5, Exercise 9F, Traversable Graphs. Again, check your logbook, see what questions you need to do for the following lesson. See you in the next and last video.